So continuing with our illustration of the independent samples t-test, it's important to note that inferential statistical tests make certain assumptions about the data that you have. For parametric tests, such as the independent samples test, or independent samples t-test, there are assumptions about the distributional characteristics of the dependent variable. One is normality of the dependent variable in your groups, and another is homogeneity of variances of scores in your two groups. This latter assumption is referred to as homogeneity of variance assumption, or the assumption of homoskedasticity. So the assumption of homogeneity of variances can be assessed most directly by utilizing Levene's test for equality of variances. So in other words, if you go back up to your descriptive statistics and you look at the standard deviations, you can see that the standard deviation in the male group appears larger than that for the female group. And the standard deviation that you compute within your samples are estimates of the population standard deviations for those two groups. And essentially the null hypothesis is that the variances, which by extension the standard deviations are computed from, the variances of those two groups are equal, so they should be equivalent. And if they are not equal, then that violates an important condition associated with the independent samples t-test. So the Levene's test, where you see where it's printed out right here for equality of variances, tests to see if there is a significant difference in the variances between your two groups. And unlike the t-test, where generally you're hoping for or looking for a p-value that's less than, say, 0.05, in the case of Levene's test, you're actually looking for non-significance. So in other words, and basically the Levene's test utilizes the F distribution. This is the significance level, and the F test is essentially utilizes like I said, it utilizes the F distribution and tests in the upper tail of that distribution. And so what you're looking for is really non-significance here for the test of equality of variances. So as you're looking right here, if you are interpreting this first row of information right here, and you're trying to interpret the t-test, you can look at Levene's test and ascertain whether or not the assumption of homogeneity of variances appears to be met. If it does not appear to be met, then you have to decide on an alternate strategy, because the violation of homogeneity of variances could lead to an inflation in type 1 or type 2 errors, meaning that you may find yourself rejecting the null hypothesis when you shouldn't, or you end up maintaining the null when you shouldn't as well. So if, based on these results, there appears to be no violation, then you would simply interpret this first row of information in your SPSS output. And in the current case, we found that the p-value that's printed out right here was greater than 0.05, and so it would appear that the equality of variances assumption, or homogeneity of variances, has been met. So we can feel more comfortable about our interpretation of this first row of information. But if this p-value right here that's printed out happened to be less than, say, less than or equal to 0.05, then that would give us cause for concern in terms of trusting our inference based on this printout right here. So we might then go to the next row, and you can see in this particular case it does not assume equal variances. So this is referred to as the Welch t-test. So if we have reason to suspect that we have unequal variances between the two groups, then one strategy to deal with that and to mitigate against type 1 or type 2 error is to go down to the second line and interpret the Welch t-test information. What happens is, with the Welch test, is that the degrees of freedom that's associated with the original test are readjusted, and you can see that actually it makes the significance tests actually more conservative. So you can see that the p-value for the, if we assumed equal variances, was a little bit less than the p-value that you saw in this case where we were not assuming equal variances. But by and large, the test was non-significant, so the amount of correction in terms of the p-values that we see right here was really minimal. So this PowerPoint was developed to give you an introduction to the concepts behind inferential statistics and its role in hypothesis testing. There are a large number of inferential statistics that are utilized by researchers, and we are only scratching the surface of those tests with one of the simpler ones in the form of the independent samples t-test. Note, if you want to know about differences between more than two population groups in terms of means on the dependent variable, there are analysis of variance models that we can utilize, and that will be covered in a different PowerPoint and video.